Good afternoon, class. We are looking at section 3.5, the chain rule. Here's part 2, implicit differentiation. Implicit differentiation. We've discussed various differentiation formulas, the definition, basic differentiation formulas involving the power rule, exponential functions, trigonometric functions, product rule, quotient rule, chain rule, and more of exponential functions. Now we want to discuss 3.5 part 2, implicit differentiation. Functions expressed by one variable are defined explicitly in terms of another variable. As an example, y equals x squared minus 2x plus 1, or in general, y is a function of x, f of x. Some functions are defined implicitly by a relation between x and y such that such examples are x squared plus y squared equals 25, or x cubed plus y cubed are 6xy. In essence, x and y may be on the same side, may be intertwined. In some cases, it is possible to solve such an equation for y, and in some cases, it's not easy to do so, and sometimes even impossible. That's why we discuss implicit differentiation. So starting with a very simple example, as a warm-up example, we want to differentiate 4x plus 2y equals 10. We want to do it explicitly as well as implicitly. Explicitly, it simply means solve for y. So we move the 4x to the right. All we have to do, divide by 2, both sides. Y becomes negative 2x plus 5, and therefore y prime is negative 2. It's very straightforward. If we were to do this implicitly, it means solve for y. It means don't solve for y, my apologies, and differentiate it implicitly. So starting with the first one, 4x, the derivative is 4, plus 2y. Remember, y is the same as g of x, everybody, or f of x. Y is the same as, let's say, g of x, f of x, h of x. Therefore, y prime or dy dx is g prime, right? So simply plus 2 y prime or dy dx, and any number results in 0. So 4x gives you 4, 2y gives you 2y prime or dy dx, 10 is a number, gives you 0. And on purpose, I used y prime here, I'm using dy dx here. They are the same thing as long as the x is the independent variable. We're going to move the 4 and it becomes negative 4. We're going to divide both sides by 2. And we get the same answer that we have here. Please understand, y prime or dy dx is the same thing. The difference is, in this case, we solved for y. In this case, we didn't have to. So implicitly done just the way it's given. And it is doable if you do it properly. We have the circle x squared plus y squared equals 25. And I want to remind you that if we have a circle centered at 0, 0 has the equation x squared plus y squared equals r squared. We want to find y prime. We want to find dy dx. We want to differentiate. So to do that, we are going to differentiate both sides with respect to x, and we're going to do this implicitly, everybody. Okay. So x squared is very straightforward, 2x. But what about y squared? I'm going to remind you of the extended power rule. The derivative of g of x to the power of n is n g of x to the power of n minus 1 g prime of x. And again, y is the same as g of x. So if I put y instead of g of x, so d dx of y to the power of n is n, g of x to the power of n minus 1 changes to y to the power of n minus 1 times y prime. Therefore, for x squared is 2x, we know that, but for y squared is 2y y prime, any number results in 0. 2y y prime, 2y y prime, extended power rule. We are solving for y prime. We're going to move the 2x. And we're going to divide by 2y, and we get minus x over. So this was done implicitly. This is a type of equation. You could solve for y and do it explicitly. It is possible. We want to find the equation of a tangent line to the circle at this pair 3, 4, which means we need two things. The pair is given. The second thing is a slope. And the slope, all you have to do, plug in, replace the x with 3. So you get minus 3, replace the y with 4, and we get negative 3. Okay, so given 3, 4, x is 3, y is 4, we get negative 3 over 4 as the slope. Point slope, y minus y1 equals m times x minus x of 1. Therefore, y minus 4 equals m negative 3/4 x minus x of 1, which is 3. Now, in this case, we are going to distribute the negative 3/4. So we are going to get this as negative 3/4 x minus 3 times minus 3 is plus 9 over 4. We are moving the negative 4, making it plus 4. As you know, 4 is 16 over 4, so we get 25 over 4. We get 25 over 4. Okay, everybody? Very straightforward. As you can see, most of them are elementary algebra. There was only one step of calculus we did, and we are done. We want to find dy dx or y prime. Again, I remind you that the advantage of dy dx is that it's telling you that x is the independent variable. So x cubed, 3x squared. Y cubed, take a look at what I wrote here, which is the extended power rule. Y to the power of n gives you n, y to the power of n minus 1 y prime. So it gives you 3y squared dy dx or y prime, makes no difference. This, we use the product rule by calling this the f function, this one the g function. This is the formula. So f prime is 6 times g makes it 6 times y, plus g prime is y prime or dy dx. Since we use dy dx on the left side, we're going to use dy dx times f, which is 6x. So we would write this is f prime g, this is g prime f, and we're done. And I'm going to put it asterisk here. We are done with calculus, and our next step is to solve for dy dx. To do so, we're going to bring everything involving dy dx to the same side, which means we are going to move this one to the left, and we make it negative minus 6x dy dx. And we are going to move the 3x squared to the right and make it negative 3x squared. So we just move things around in one shot. On the left side, we are solving for dy dx. We have to factor out the dy dx. So if I factor out the dy dx, also I notice there is a common factor of 3, which means now we have 3 times y squared minus 2x times dy dx. Again, we are just simply factoring everybody. We are factoring. On the right side, there is also a common factor of 3. So if we divide both sides by 3 times y squared minus 2x, we can cancel out the common factor of 3, and dy dx becomes 2y minus x squared over y squared minus 2x. We're going to continue with more examples. We want to find dy dx of y prime. Again, I'm going to put a raised dot here, meaning I need to use the product rule again. 4x squared gives me 8x times g. So this is f prime g is y. Okay, f prime g plus g prime f. G prime y gives you y prime times f, which is 4x squared. Then plus 2y squared. This one, I use the extended power rule. Instead of g, I'm going to use y. So it becomes 4y prime. Please understand, it comes from here. And any number results in 0. The right side is a number, 18 or any other number. Again, we're done with calculus. We are going to combine anything involving y prime to the same side. Anything other than that, we move it. So these two pieces, we keep it and we factor out the y prime. Of course, there is a common factor of 4. Everybody can see that there is a common factor of 4. So in essence, we take out 4y prime, and that gives us x squared plus y. What about this one? This one, we move this to the other side, becomes minus 8xy. So this moves, becomes negative on the other side. So all we have to do, divide both sides by 4 times x squared plus y. Negative 8 cancels out the 4, changes to negative 2, and the final answer is y prime is negative 2xy over x squared plus y. That's the final answer. Four x squared plus 6y plus y squared equals e. We want to differentiate this implicitly, so we go term by term. 4x squared is 8x. 6y, you can say 6y prime or 6 dy dx, it's up to you. Y squared, we use the formula here, the extended power rule, plus 2y prime. E is a number, that gives you 0. Again, we are done with calculus step. Anything involving y prime we keep, the other one we move, and these two we can factor out not only y prime, we can also factor out number 2. Therefore, when we take out 2y prime, this gives us only number 3. This gives us y, and 8x moves, becomes negative 8x on the other side. becomes negative 8x on the other side. All we have to do is to divide by 2 times the parentheses. In other words, divide this one by 2 times 3 plus y, the same thing here. And as you can see, negative 8 and 2, they result in negative 4 in the numerator. The final answer, y prime or dy dx, is minus 4x divided by 3 plus y. This is your final answer, everybody. We continue with differentiation, and we want to find the derivative of x e to the power of y plus 2y cubed equals 3x implicitly. I'm going to put a raised dot here and call this f, call this g, and again I'm going to use the product rule. F prime is just 1 times g e to the power of y. What about e to the power of y? Please understand, in essence, you are here. You're dealing with the exponential function of e to the power of g of x. The derivative is e to the power of g of x times g prime of x. So the derivative of e to the power of y is itself times y prime. So take a look at this one, times y prime, or you can think of it as this format. So e to the power of y times y prime, and then times x by the product rule, by the product rule. This is g prime f. 2y cubed, using this formula, 6y squared y prime. The right side is just 3. And again, just to make sure we are following this properly, this is f prime. G prime f, okay, for this part only. Again, we're done with calculus. So what do? We keep everything involving y prime on the same side. That means these 2 pieces, and we factor out the y prime. When you factor out the y prime here, it gives you e to the power of y times x, or x times e to the power of y. This one gives you 6y squared, and the right side is 3. This moves to the right. This is 1 times e to the power of y, or simply e to the power of y, and that becomes negative. So this moves and becomes minus e to the power of y, okay? All you have to do, divide by the parentheses, and you're done. So again, look at the calculus step and look at the rest of it, algebra. Pretty straightforward. We want to find the equation of a tangent line to the graph of this function x squared y squared equals 1 at the pair negative 1 comma 1. And this relation in essence. So we need 2 things to find the equation of a tangent line. We need a pair x comma y, which is given. We also need to calculate the slope. And to do so, we have to differentiate, and we are going to differentiate implicitly. So I'm going to put a raised dot in between. I'm going to call this f times g. F prime is 2x times g, which is y squared, plus g prime, again y squared. I'm reminding you that I'm using the extended power rule, 2y prime, and then times x squared because of the product rule. The right side is a number resulting in 0. Any number results in 0 when you differentiate. So we are going to keep this and move this to the other side, becomes negative. So this has moved. It's negative now. We are going to divide both sides by 2yx squared, and we keep the y prime. And I hope you see everything cancels out except minus y over x. In other words, do the elementary algebra and find the result. Okay. So this is not the slope, everybody. This is the derivative of the function. It becomes a slope when it's evaluated and it becomes a number. So replace the x with -1 and the y with +1, and that gives you 1. By the way, this is the notation that says m is this function evaluated at this pair. The reason we write it in this format, because it's not like y, or in this case y prime of just -1 or 1. We have to plug in both. And now, of course, y minus y1 equals m times x minus x of 1. So y minus 1 equals m, which is 1. X minus -1 makes it x plus 1. As you can see, the right side is just x plus 1. Move the -1 and make it x plus 2, and you're done. As always, the pair belongs to the original function, also to the equation of a tangent line, because it is the point of tangents. And all it says that this process is done right. It doesn't say whether we calculated our differentiation derivative or the slope right. That is not the case. We're going to switch gears and we're going to look at applications. One application is known as related rates. If you are pumping air into a balloon, both the volume and the radius of the balloon are increasing. And the rates of increase are related to each other. But it is much easier to measure directly the rate of increase of the volume than the rate of increase of the radius. In a related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. What is the procedure? Find an equation that relates the two quantities. Then use the chain rule to differentiate both sides with respect to time. So in the case of related rates, the independent variable is t, everybody. So dy dt is dy du dt. This is the Leibniz's notation. As we go from y to t, the intermediate variable happened to be u. Same question with numbers. Air is being, this is a warm-up example, air is being pumped into a spherical balloon so that its volume increases at the rate of 100 cubic centimeters per second. How fast is the radius of the balloon increasing when the diameter is 50 centimeters? It is important to understand the problem. This is a word problem, has to be translated. Has to be translated. So what is given? The rate of increase of the volume of air is 100 cubic centimeters per second. What is missing? The rate of the increase of the radius when the diameter is 50 centimeters. Now we want to translate this, and we are fine. How do we translate this? First and foremost, the volume of a sphere has a formula of 4/3 pi r cubed. We should know that. It's a piece of information from algebra, geometry, you name it. And the relationship between a radius and diameter is that these two are. Therefore, we use this formula. Given dV dt is 100 cubic centimeters per second, we want to find dr dt when the radius is 50 divided by 2, or 25 centimeters. This is the part you need to say you've translated this into this beautiful language of math, and you're ready to move on. So what do we want? We want dV dt, and that's dV dt. What is the intermediate variable? V is a function of r, radius. So the intermediate variable is r. So you want dv dr times dr dt. And to differentiate this, volume is 4/3 pi r cubed. 4/3 pi is the number. So you write 4/3 pi and then times r cubed gives you 3r squared. And it's r is a function of t. Therefore, you have to tag along dr dt. So this is because t is the only independent variable in the case of the related rates. We can simplify the 3 cancels out the 3. We end up with 4 pi r squared dr dt. We can plug in and come up with dr dt. Or better yet, if we divide by 4 pi r squared, now we are practically ready to plug in. So dv dt is 100 cubic centimeters per second. You can put the units also. 4 pi times r is 25 squared. Now, for this one, you have to put this. And again, I want to make sure that you understand why we end up with the proper units. This one and this one is centimeters, and it's being squared, right? R squared. So that's why you get the proper units, which is for dr dt, the change in radius over the change in time, which becomes centimeters per second. Notice 4 times one of those 25 is 100. So we have 1/25 pi. This is a precise answer. And in calculus, we need the precise answer unless otherwise mentioned with however many decimals. So the radius of the balloon is increasing. Why is it increasing? Because this has a positive value, right? Increasing at a rate of 1/25 pi or 0.0127 centimeters per second. This is an approximation, class. Okay, and I want you to pay attention to that. Why it's an approximation? Okay, because you are going to use the pi as 3.14159 and it continues indefinitely. That's why you just don't want to truncate it too early. So you want to pay attention to however many decimals they ask you. Can somebody read the question, please? Go ahead, please, somebody.
A small rock is dropped into a lake. Circular ripples spread over the surface, with the radius of each circle increasing at a rate of 3/2 feet per second. Find a rate at which the area of the circle is changing when the radius is 4 feet.
Perfect. Thanks. So, information from geometry/algebra. The area of a circle is pi r squared. Everybody knows that. The diameter d equals to r. Circumference is 2 pi r. In this case, we need this formula, not the rest of it, because we are relating the area to the radius. But I wrote all of them just to remind you. So A equals pi r squared is what we need. What is given? The radius is increasing at this rate. So dr dt, the moment you hear rate, this means differentiation. Dr dt is 3/2 feet per second. What do we want to find? The rate at which the area is changing. So we want the ADT when r is 4 feet. This is the translation of the question into math. Again, I put a bunch of formulas here. This is the one we need. So we are going to differentiate this. With respect to t or time. So if a is this, the ADT is pi, is the number, times r squared, 2r dr dt. R squared gives you 2r dr dt, or 2 pi r dr dt. So all you have to do, replace the r with 4, replace the dr dt with 3/2, and please understand that means 4 feet. That means 3/2 feet per second. That's why the units are square feet per second, as they must be, the units of area over units of time. Okay, so when you do the math, these two cancels out these two. 4 times 3, 12 pi square feet per second. Those are the units. Again, this is in feet, this is feet per second, and it works. Or just look at this one. And this is an approximation with 4 decimals, class. Again, if they ask you. So when you show your work, you show the exact answer, and then if you want to approximate it according to what they ask you. Find dy dt for the equation 4x plus 3y to the power of 4 equals x squared, where dx dt is 10, x is 4, y equals -2. What I want you to pay attention to is the denominator. That gives you dt. That gives you t is the independent variable. That means we are differentiating with respect to t. That means even x. Notice the derivative of x is no longer 1. They put dx dt. And that's important to understand. So 4x doesn't give you 4, everybody. 4x gives you 4 dx dt. Y, x is not the independent variable. What is t? How do you know that? Take a look at the question, dy dt. That's why the Leibniz's notation gives you precisely what is the independent variable. Now this is simple, and we use this formula. 3 times 4, 12, y cubed, y prime. Now in this case, we're not going to write y prime. We're going to write dy dt. Okay, precisely dy dt. If you wrote y prime is not wrong, but it's with respect to t, so definitely dy dt. And of course, x squared is 2x dx dt. Done with calculus. Done with calculus. Now, since they want you to evaluate, you can plug in. So if we plug in, class, 4 times dx dt is 10 plus 12 times y -2 cubed. dy dt, I have no idea, it's missing. 2 times x is 4, dx dt is 10. So this is 40, this is minus 8 times 12 is minus 96. The right side is 80. You subtract this. From 80, you get 40 and divide by -96. And it simplifies to -5/12. And that's absolutely fine, and that's pretty fast. However, just for practice, class, if they said solve for dy dt here, and they didn't give you any of those values, you have to solve for the dy dt rather than plugging in. So let's see how it's done. You want to solve for dy dt, just keep that and move this. Keep that and move this. That's all. Okay. So we are going to move this one becomes negative. All you have to do, divide both sides by 12y cubed. When you divide by 12y cubed, remember that the right side, they have a common factor of 2. You can write it this way. So therefore, this 2 can go away to change the 12 to 6. Okay. So that's why I want you to see that. Okay, everybody. All right. I think that's pretty straightforward. In this question, we want to find dx dt. Right away, we recognize the independent variable is t. Okay. For the equation that is given, dy dt is given. x is given, or this equation, 3x plus y e to the power of x equals 20, dy dt is negative 8, x is 10, y equals negative 1. So what we do, we are going to differentiate this step by step, starting with 3x. We get 3 dx dt. Y e to the power of x. Let me put a raised dot in between and making sure everybody recognizes this uses the product rule, everybody. Y, you don't want to write y prime. You want to write dy dt times e to the power of x plus e to the power of x is itself, e to the power of x, times dx dt times y. So again, e to the power of x is itself, but remember, x is not your independent variable. X is a dependent variable and it depends on t. So that's why you tag along dx dt. This is because what they're asking you here, and of course, this is by the product rule. Let me write this as f prime g plus this whole thing is g prime f. Okay, everybody, we need that. And so we're done. We just want to solve for dx dt. We can plug in and see what we get. We can also solve for it later on. So dx dt is missing, everything else is given. So we're going to plug in everything that we have. Let me just show you. This one is missing. Dy dt is negative 8. E to the power of x is 0. Same thing here. Dx dt is missing. Y is negative 1. And I hope you realize, so this is 3 dx dt. This is 1, right? This is 1. So this whole thing is negative 8. This is 1. So this is simply negative 8. This is plus 1 dx dt times negative 1. This is minus dx dt. And we can combine these two to get 2 dx dt. Minus 8 moves, becomes 8 divided by 2 is 4. Okay. If we were to solve, okay, if they asked you to solve, class, because you want to solve for dx dt, you're going to keep this guy, you're going to keep this guy, and you're going to move this to the other side. So when you do that, it takes a negative sign, everybody. So this one remains. This one moves, and it becomes negative. This one moves, and it becomes negative, everybody. So on the left side, you are interested in dx dt. If you factor out the dx dt, you get 3 times y e to the power of x. And practically you're done, just divide by the parentheses. And if you plug in, everybody, you get to the same answer. If you plug in, you get to the same answer. We want to find dy dt for this equation. Dx dt is given, x is given, y equals negative 9. And what happens is that we notice again, t is the independent variable. So we want to differentiate this. Dx dt is given, x is given, y is given, dy dt is what we are interested in. So we are going to use the chain rule. 4 sits in front, and then 5x plus y to the power of 3. And then the derivative of the inside. Now, here's interesting. 5x gives you 5 dx dt. Y gives you dy dt. So again, 4 sits in front. The same thing to the power of 3. So n sits in front. You have x to the power of n minus 1. G prime of x, the derivative of the inside, 5 dx dt plus dy dt, minus x is dx dt, and 6, any number is 0. And we're done. Again, you can solve for dy dt or just plug in. I'm going to plug in and I'm going to leave it for you to solve this as an example. So if we plug in, that means we replace the x with a 2. So we get 10 here, y with negative 9. So this is 5 times 2, 10. And this is negative 9, 5 times dx dt, we replace it with 3. Dy dt, we don't have it. Minus dx dt, we replace it with 3. So again, I want to make sure that we understand that this one is 5 times 2. Okay, so that one is 5 times 2, everybody. So I want to make sure that we understand this. Okay. So all we have to do, simplify, and we are in good shape. Well, 10 minus 9, 10 minus 9 is 1, and 1 cubed is 1. 5 times 3 is 15, and we write it. So we write 4 times 1, we don't have to write. 15 times plus dy dt minus 3. Okay, so again, 10 minus 9 is 1. 1 cubed is 1, so it has no bearing. We write this, we write it at top. So this one is 15, everybody, okay? And this whole thing is 1. And so we move the negative 3, and to do that, first we're going to distribute 4 times 15 is 60 plus 4 dy dt minus 3. And as you notice, on the left side, we have 57. So we can move it to the right, becomes negative 57. And now we can divide by 4, and dy dt becomes minus 57 over 4 as the final answer. So very straightforward, everybody. Okay. Could somebody read this question, please? Anyone? Falling sand is forming a cone-shaped pile. The volume of the cone is increasing at a rate of 54 pi cubic inches per minute. The height of the cone is twice the radius of the base. Find the rate at which the radius changes when the radius is 6 inches. So what do we have to do? Number one, we need to remember the shape of a cone, the volume of a cone, which is 1/3 pi r squared h. So we need to remember the shape. We need to remember the volume, 1/3 pi r squared h. So that has got to do with the prior knowledge of mathematics, from geometry, from trigonometry, you name it. So we have this formula to do. Let's go back and read. The volume is increasing at this rate. So dv dt is 54 pi cubic inches per minute. The height is twice the radius, so h is 2r. H is 2r. Very straightforward, right? Find the rate at which the radius changes. So that means find dr dt when radius r is 6. So this is the translation of the question. So quickly, let's recap. V is 1/3 pi r squared h. dv dt is 54 pi cubic inches per minute. H has the relationship with the radius as h equals to r. dr dt is missing. R is 6 inches. So we are going to differentiate V and come up with the answer. Now, in order to do that, we notice we have two variables, R and H. So if we were to do that, we have to use a product. However, we don't need to do that. We know there's a relationship between the two. Because I want dr dt, I'm going to keep the R and I'm going to get rid of the H. If they were asking for dh dt, I would keep the H and get rid of the R. So how would I do that? All I have to do, instead of H, I'm going to put 2R. Otherwise, I would keep the H, and then instead of R, I would put H over 2. Please understand, R is H over 2 if I wanted dh dt. So this becomes 2/3 pi R cubed. Now I have one variable, namely R. Now I'm going to differentiate. And to differentiate, I'm going to keep the number 2/3 pi. That is not going away. And I'm going to just differentiate R cubed, which is 3R squared dr dt, everybody. 3R squared dr dt. Now we are going to simplify into 2 pi R squared dr dt. We want to differentiate this. We want to set this equal to 54 pi cubic inches. And we want to replace the R with 6. So this is your dv dt. And dv dt is what? dv dt is 54 pi numerically. On the right side, remember pi is a number, is not missing. R, replace it with 6. So left side, replace it with 54 pi. Right side, replace the R. Replace the R and just do the math. So what do we have here? 36 times 2 is 72. So we have 72 pi on the right side. So I'm going to divide both sides by 72 pi. Obviously, the pi's cancel out. 54 and over 72 become 3 over 4. And the units, inches per minute. The units of dr dt, the change in radius over change in time. And even if you go back here and put each one, this one you put it with the proper units, cubic inches per minute, and this one you put it with inch being squared, you will get to the same answer, everybody. Okay. $18 is in common and it comes out. Can somebody read this question for us?
A 20-foot ladder. Oh, my bad.
Go ahead, please.
A 20-foot ladder leans against a building. The base of the ladder slips away at the rate of 2 feet per minute. Find the rate of the change of the height of the ladder when the base is 12 feet from the building.
Perfect. Thanks. So let's look at the situation. Here's the building, the wall, here's the ladder, and it moves this way and creates this situation. So this goes to the right, this comes down, right? The length of a ladder is fixed at 20 feet, and I'm going to call it, remember, a squared plus b squared equals c squared. So c equals 20 feet, or L, the length, whatever you want to call that. This way, it slips away dx dt at 2 feet per minute, and it comes down at dy dt, which is missing, which we have no idea. So we are going to use Pythagorean theorem, a squared plus b squared equals c squared. Okay, so we have x squared plus y squared equals c squared, and c is fixed as at 20, therefore 20 squared. Now, dx dt is 2 feet per minute. We are looking to find dy dt. When? The base is 12 feet from the building. X is 12 feet. This is you have to draw the setting. And then you have to do the translation in this format to make sure you can handle this question easily. So now all you have to do, differentiate this part, 2x dx dt plus 2y dy dt. 20 squared is 400, class, but anyways, it's a number. You just write down it's 400. This is 400. No, it doesn't look good. And the derivative of any number is 0. Now, we have everything we can plug in, except when x is 12, everybody, we don't know what y is, so we just plug it into Pythagorean theorem. So x squared plus y squared equals 20 squared. X is 12. Find the y, and obviously this is 400. This is 144. Subtracted, take a root, and y becomes 16 feet. Now plug in. We have everything. Plug in. We have the value of x. We have the value of dx dt. 2. We have the value of y. The only thing missing is dy dt. 2 times 2, 4 times 2 is 48. 2 times 16 is 32. Therefore, dy dt, we move the 48 to the other side. And divide both sides by 32. And it gives you negative 3/2 feet per minute. And notice, x is getting longer, it's getting larger, it's increasing, dx dt is positive. Y is getting smaller, and obviously dy dt must be negative. It works out properly. Now, if the question is, at what rate is decreasing, of course, you answer it with a positive value. We're going to look at the same question. When it slips away, okay, the same question, a 20-foot ladder leans against the building, the base of the ladder slips away at the rate of 2 feet per minute. Find the rate at which the angle between the ladder and the ground when the base is 12 feet from the building. So when the thing happens, other things happening also. So this moves this way, this moves this way. This angle changes. This angle, also this angle, but this one between the ladder and the ground, okay, that's why you want to be careful. It's given between ladder and the ground. It's this one. So we know dx dt is 2 feet. We are interested in d theta dt, okay? So that is extremely important to pay attention to. What is it that they are asking you, okay? What is it that they are asking you? Which angle? And again, the same situation, dx dt is 2 feet per minute, x squared plus y squared is equal to 20 squared. We need that to find the missing values if we want it. And d theta dt is missing when x is 12 feet. So all of the above, it's very similar to what we had before. Okay, so this is the same as before, except this part is what we are looking for. Okay, everybody? We are looking for d theta dt. We are looking for d theta dt. And I remind everybody that we are dealing with a 90-degree angle here. We are dealing with a right triangle, and the sine is the opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse, okay? We should know that. And since we have dx dt, then we're going to use the x, and we're going to say cosine theta is x divided by 20. We're going to use this formula. Again, we've already calculated the value of y from the previous page. We're going to use that, but what if we made a mistake with our calculation? Use the given. So the given, it helps to use this one. So cosine theta is x over 20, and sine theta is y over 20. But we are going to use this one to differentiate. And to make sure we understand what's going on, I'm going to rewrite this as 1 over 20 times x, although everybody knows that. But anyways, cosine, the answer is negative sine. Negative sine of what? Theta times, so negative sine. So you can, again, pause here. Cosine gives you negative sine. It's negative sine of what? The same variable, theta. D theta dt. This one, because theta is a function of t, because theta is not an independent variable. And this one is 1 over 20 times x becomes dx dt. 1 over 20 times dx dt. Okay. Again, very straightforward. Now, we recall that y was 16 from the previous page. And we want d theta dt. So it's minus y over 20, 16 over 20. So minus sine theta y over 20, 16 over 20. D theta dt on the right side is 1 over 20. Dx dt is 2. And I hope you realize when both sides have the same denominator, you can drop it. So that means minus 16 d theta dt equals 2. Divide both sides by negative 16. And you get negative 1 over 8 radians per minute. Be very careful with your units. The denominator are the units of minute. Okay, so dt time has a units of minute. And this is in radians. And why is it negative? Look, as it comes down, theta gets smaller. So minus 1 over 8 d theta dt. Minus 1 over 8 d theta dt. We're going to look at the last question. A spherical balloon is deflating or losing 8 cubic centimeters of air per minute. At the moment when the radius of the balloon is 20 centimeters, how fast is the radius decreasing? And I'm reminding you of the volume, so we need to memorize this formula. We already know that from algebra/geometry. And this is dv dt. This is dv dt. Now, the only thing I want to emphasize, when it's losing, that means negative. So minus 8 cubic centimeters per minute. So the units are cubic centimeters per minute, but it's minus. And we want dr dt when r is 20 centimeters. So this is the volume we are supposed to know. dv dt is 8, but we have to write negative because it's losing air, because it's deflating. And that's really the key. So let me just make sure. So this or this results in this sign. And of course, this would be the units, and the RDT is of interest to us. We've already done this, 4/3 pi times 3r squared dr dt. We've already done that. You can go back to your notes, which makes it 4 pi r squared dr dt. Let's plug in what we have. You can divide both sides by 4 pi r squared. And we did that in the previous one. In this case, I'm going to just plug in. So I'm going to replace the dVdt with -8 and replace the R with 20. This is 400. So we have 1600 pi dr dt. We are going to divide both sides by 1600 pi. Obviously, 8 cancels out the 1600, and we get -1/200 pi. The units are right from here, the units of the change in radius over change in time, so centimeters per minute. This is precise, and you put it into a calculator. Pi is not 3.14 class, it's 3.14159, and it continues indefinitely. So dRdt is -1/200 pi, or -0.00159 centimeters per minute. As far as the number of units, number of decimals are concerned, you have to see how many decimals they want you to use.